Let's all welcome the APJ Security Chief Technology Officer of Akamai Technologies, Michael Smith.
Cool. So thank you, everybody. I had to laugh when Zdrava came out. She had the picture of the Hong Kong airport. I was in the airport, same airport, 3 weeks ago, maybe a little bit more than that. And I went past the Chanel display, and I was like, oh my God. So I pulled out my phone, and I took a picture of it, and I sent it to my boss, and I said, look, data centers are cool now. We're cool. You know, nerds are awesome. We rule the world. Okay? So when she came out, I just had to laugh. I had a huge laugh, and I kind of distracted her. So my name is Mike. I work for a small internet startup. I have no slides up. Oh, hang on. Okay. I work for a small internet startup called Akamai, and then we grew, and then we grew, and then we grew. Today, we deliver about 30% of the World Wide Web, and we have enough people presence that my company moved me to Singapore to support all of Asia in our security efforts, okay? But because what we do is it's a little bit abstract, it's hard for people to visualize, so I've got a quick video that I'll show that it kind of explains what we do.
Every minute, every second of every day, every single digital experience must perform flawlessly, which means keeping today running while building for tomorrow is an uncompromising challenge. Akamai helps make it easier. Because when sensitive transactions are at stake, we ensure our customers are secure. When critical teams need instant access, we keep everyone connected. When there are no second chances to get it right, we help deliver the ultimate experiences. And when the stakes are incredibly high, we give innovators confidence. Governments, hospitals, and the world's top businesses trust Akamai's people and technology to deliver today, while preparing for what's next. Akamai is the world's largest and most trusted cloud delivery platform. We make it easier for companies to provide the best and most secure digital experiences. We are Akamai.
Okay. So many, many years ago, so I've been with Akamai for about 7 years, a little bit more than that. And when I was first hired, we had our new hire orientation. And so I came and we talked about, why is the internet bad, right? Why is it not made for reliability? And what are the problems with doing e-commerce, doing streaming video? What are the problems with attacks? And then we did a little workshop. And part of the workshop was to come up with what's the new company tagline. And me being a paranoid IT security guy, I said, well, that's really, really easy. How about the internet sucks, we help it suck less, okay? And the sales and marketing people are like, no, that's horrible. Security people, yeah, we go, yeah, that's absolutely right. It does suck. And by what I mean by that is that if you look at the company in general, was a problem with the internet back in 1994 when it was first released. It first went public, and people started putting up websites, and they were brochures. Okay, so they're basically like the 5-page printed brochure, but put up online. Okay, and then they started to add forms, so you could download a PDF form and you could print it out and fill it out and send it in. Or they added something that was like the contact us, and that would pop up an email dialogue in your email client, and you can write an email and send it to somebody. Or worst case, they would give you, here's our phone number, and you could use that to call. Okay. Well, back in 1996, 1997, Tim Berners-Lee, who created the web, he was a guest lecturer at MIT, right? And he said, look, the web won't support e-commerce, right? It's not fast enough, it's not reliable enough, and you guys are MIT students, you're smart, go figure it out. And one guy's project, his PhD project, was how do we actually make the web work and support these systems? And that's what happened, and that turned into Akamai. And basically what had happened is we built out websites to right in the middle of this kind of spectrum where we had basic functionality, but it just wasn't reaching people, right? And we had lots of fails. We had a lot of websites that had sales for Christmas. People would go there, and suddenly it would crash, okay? And then we added more functionality, okay? Now, today, inside of the Philippines, we're about right in the center there, okay? Where we've got a lot of government organizations. I saw a statistic from a couple years ago that said 15% of government organizations inside the Philippines didn't even have a website, or their website was offline, okay? So that's kind of a problem. We're seeing it in other places where we've got, especially inside of Southeast Asia, we have a lot of native companies that are doing e-commerce, but we're not seeing native companies inside of the Philippines yet. We will. It will happen, okay? We're seeing lots of advanced technology here where we are delivering websites to mobile devices, okay? And mobile devices have their own performance challenges. For the Philippines, that's absolutely huge because everybody has a mobile device, but they might not have a desktop at home, okay? Now, the interesting thing about this model is that as you increase your functionality, increase your usability, increase what people are doing with your website, you also increase your attack surface, okay? So you have more functionality, that means that there's more functionality to abuse, okay? The more stuff that's there, the more stuff there is to break into. Also, there's a step where as you move most of your business online and you start doing more and more and more business online, that website becomes more and more critical to your business and what your income is and what you're actually producing, okay? And so we run into problems, and we're starting to see it inside of ASEAN in general, where companies are moving more and more stuff online, but they don't realize that they now have this increased dependency, and so they're not investing in actually protecting that and accounting for that increased attack service, okay? So let's look at the global view. Back it up a little bit. I have two different types of attacks that I normally deal with, okay? And so I was the founder of our incident response team, and I helped build a lot of our security products. But I have two basic types of attacks that we deal with. Some are going to be very, very big, okay? And you'll see about these in the press. Those are the volume attacks, or what we call distributed denial of service attacks, where you either have a bunch of users that opt in and send a lot of traffic, or you have a lot of bots, and you see some of these like Mirai, even some worms send a lot of traffic. But they send a lot of traffic and flood out the network for whatever that target is, whether it's a website, sometimes it's email, sometimes it's DNS, okay? The other type of attacks are very, very small attacks, okay? And in a web application security world, what you're looking for is 20 requests, 20 HTTP requests that get detected and blocked, okay? That's what success in that world looks like. So we've got a quarterly report. You can see the URL here. We actually have two quarterly reports. The first one is connectivity. So what's the average broadband speed in a particular country? How do they rank in the world? How people are consuming media? What devices are they using? That isn't as interesting to me because I'm a security guy. But we do have a security report that comes out. We just released it 3 weeks ago, I believe. And I'll show you a little bit of the findings of it. Okay? So this is the first one. I joke with the guy who's the author of the report, and I said, okay, that's nice. But that's basically the population of Asia, plus Japan, plus Singapore, because they're developed nations. Okay? So I teased him a little bit about it. It's very, very hard to get statistics on web application attacks because they are so small and so distributed. Okay? The other thing is that it doesn't tell me a lot on like who is attacking the Philippines. So I have a project that I've been working on, and I'll talk about that, where I've been trying to get information on a country-by-country basis to help people understand what the problem is. Okay? This one is actually really pretty. Somebody told me I should put it on a t-shirt. But this is for the past 2 years, every dot is a distributed denial of service attack. Okay? And you can see there are 3 basic trends out of here, and I'll build this out. Okay? 3 basic trends that are evident here. The first one is the frequency of attacks. Okay? So if you see on the left-hand side, which is 2 years ago, they're not very frequent. Okay? You can see space in between the dots. But by the time you get to the last quarter, you see that the dots are almost a continuous line. Okay? So you have this kind of visual. It's becoming more and more frequent, more and more of a problem. The second trend is that the average size of attacks has actually decreased over the past year. Right? Where today, if you have maybe 5 gigabits of mitigation, right? So 5 gigabits of network to actually mitigate the attack, you're protected against 95% of the attacks that are out there. Right? That still leaves 5%. And that's my third trend, which is the mega attacks, which is what we call them. Those are attacks that are larger than 100 gigabits per second. Okay? And actually, last quarter, we had a decrease. We only had 2 last quarter. But the quarter before that, we had a bunch of them. I don't know the exact number, but it was a lot. Part of that was because of this new bot called Mirai that came out that attacked a lot of our customers. Okay? Now, if you look at what people are actually hosting on inside of Asia, the average website is hosted on 2 500 megabit per second links or 2 1 gigabit per second links. So you throw 2 gigabits of attack traffic at that website, you'll actually get it to roll over. Okay? The mega attacks themselves are a little bit of a trend that we've been watching, mostly because it's an attack against us as a mitigation provider, or it's an attacker that builds a bot that's big enough that they didn't build the good controls into it, so they can't actually send a small amount of traffic. Right? But as a provider, we're constantly trying to say, how can we build a bigger, better platform to deal with these larger attacks, because we know that we'll get more and more and more of them over time. Okay? One of the new attacks that we talked about in our last report was what we call the DNS Water Torture attack. Okay? And in a DNS Water Torture attack, what you do is you have a bot, you create a random host name, you send it to the bot and tell the bot to request that. Okay? So you see right here in the center, that's actually the DNS resolvers at the ISP, okay? Or whatever the enterprise is. But the way DNS works is that if you send a request and there's no answer, the DNS resolver will keep trying to find the answer to that and basically flood out the target's DNS server. So you could basically use the ISP's resolver as an amplification network. You send 1 request to it, and it turns around and sends 10 requests to the target. Okay? So we saw that. That's one of the things that's scripted inside of the Mirai bot. Okay? Earlier this year, we had a group called Stealth Ravens. Now, you can see this is one of their emails that they send with the good English and everything. But they're a group. There was a group 2 years ago called DD4BC, which was DDoS for Bitcoin. And DDoS for Bitcoin, or DD4BC, they sent messages like this. So they'd say, hey, you've got a really nice website. It would be a shame if something happened to it. If you pay us some amount of Bitcoin, then nothing will happen to your website. Okay? So those guys were arrested last year in Bosnia. But they set up this pattern or this method of operating that everybody else is now using. And so maybe once every 3 months, once every 4 months, we'll see a new group that comes on the scene that pulls exactly the same kind of thing. Now, these guys in particular, they lie. So they say, oh yeah, we're using Mirai, which is this one bot that was used back in October. They don't use Mirai, they use simple scripts. They say that they can throw 1 terabit per second of attack traffic. They can't. You know, they're throwing maybe 5 to 10 gigabits per second. There are lots of different lies that they tell. But for the most part, these guys will come, they'll send the protection notice, they'll send a small attack sometimes, about half the time. And then the rest of the time, they don't even attack. And I don't know of anybody that's actually been attacked for not paying them. Okay? But it's kind of one of those where they sort of echo what's happening inside of ransomware, but they use DDoS. Okay? Threat advisors. So we've got a lot of different information that we have that's derived from the platform, from incident response, and we try to make that available to everybody. And we put it out on our corporate blog. We release our advisories. If you go to the State of the Internet site, you can download these. If you have any questions, call us, ask us. One of the things that's a big trend inside of Asia, and it's been inside of North America like 5 or 6 years ago, which is information sharing. So we're seeing a lot of people that have picked up the flag for information sharing. Basically, the idea is that where one organization gets attacked, they take that information and share it with somebody else, okay? So that way you can look for it also. Things like Stealth Ravens, when they hit the Philippines back in March, they hit all of the FSIs, some e-commerce, all within the course of a week, okay? But understanding that nobody actually gets attacked except for that one initial attack, that helps out so you can build a better response. You can know how to deal with them. And so there's this trend right now inside of the rest of Asia to build information exchanges so that organizations can share information with each other as they need to. Okay? Moving on to the Philippines. I've got this engine. We call it CSI. Right? Honestly, I think it's an acronym that we then tried to figure out, like, what does it mean? All right, so they named it after the TV show, and then they're like, oh God, what does it mean? So it means Cloud Security Intelligence, okay? But really inside of it, it's just a big Hadoop cluster, okay? So we use like a lot of big data concepts behind it. We feed it stuff. So we feed it web application firewall data. We feed it regular content delivery network logs, so web logs, in a couple different flavors. And then we use some machine learning to teach CSI how to identify attacks. Okay, that's really, that's kind of cool. But it's mostly how we use it and apply it. Okay? And as we identify attacks, and there are 4 different categories, you guys can read them. But as we identify attacks, we can do different things with them. So one is we can keep a reputation of each source IP address to say, oh yeah, we've seen you attack customer A, customer B, customer C. When you go to customer D, you're probably also going to attack them, so we'll just block you before we even look at the traffic you're sending. Okay? Another thing that we can do is that a couple years ago, we discovered that our customers were having problems actually managing web application security. Okay? It's very, very esoteric. It's hard to understand. It's very, very detail-oriented. And so we use the CSI platform to look at their particular security policy and say, well, here's a false positive. So this thing keeps getting triggered by your security policy, but it's not really an attack. That's normal user behavior. And so here's how you should change your policy so that this doesn't keep getting flagged and blocked. Okay? Another thing that we did was we set up our own default WAF policy to be the most accurate that we could. Okay? So we generated this feedback loop so that we can say, well, here's a problem, let's fix that for everybody else and work on the accuracy of the WAF. Okay? And it's really simple. You say, here's a normal body of attack data, here's a normal body of regular, good, clean data, stick that into machine learning, and then look at the traffic that you're hitting in production and say, hey, you know what? That's probably good traffic. Okay? Another thing that we did was we generated data feeds, and I go in and mine these things. So this is for just a small sample of my customers in the Philippines. And basically across the bottom, what you're seeing is a day by day for each of these 4 actors. Okay? And they're web scrapers. So scrapers aren't necessarily an attacker, but they do request a lot of volume out of a website. And so we'll treat them as attackers in some cases in some sites. We've got scanning tools. So they will check multiple things inside of a website to see if there's any hole. So it's like walking down the hallway, checking doors to see if there's one that's open. Okay? And then once there's one, you find one that's open, you go in and steal everything. Okay? Web attackers, so that's once you found a door that is open, go ahead and break in and steal everything. And then DOS attackers, so they send lots of volume. Okay? So you can see at the bottom here, basically here's the attacks over time. And that's kind of, that's pretty normal. You kind of see that sort of the web attackers, you see little bits here and there, but from a huge variety of sources. DOS attackers, you see not a lot of them, so not a lot of sources, but when they do attack, they send a lot of requests. The scrapers, not a lot of sources, but they do send a lot of volume. In fact, if you look on the upper right-hand corner, that's sorted by number of requests. So scrapers send a lot of requests. That's what defines them. That's what they do. And then on the left-hand side, we've got the upper left-hand side is sorted by source IP addresses. Okay, so you can see there are a lot of web attackers, but they don't come up on the volume side. They don't send a lot of requests. Okay, now network sources. This is pretty typical. Amazon has a lot of scrapers because if you're going to build a bot to go scrape a website, you go to Amazon, you set up a server instance, set up your script, and then just start scraping everything. Okay, so we get a lot from there. Some other hosting providers, like usually OVH is on there, Alibaba. Okay. Scanning tools, up at the top you've got Jinrong Street. That's the Great Firewall of China. A lot of stuff coming from there. Usually you see, PLDT is usually in there, Telecom Malaysia, kind of that slice of Southeast Asia, and then South Asia, we get a lot of attacks from there. Okay? And then DOS attackers, there's one anomaly that showed up, and that's an attack on one of my financial services customers coming from Brazil in relation to one of these hacktivist attacks. Okay, so it's basically people are mad at the banks, so they go attack banks. Okay? Now, out of this, a couple things, and how are people dealing with it? How are people dealing with attacks out there? Okay? For security managers and CIOs, it really starts with just awareness first. Okay? Very, very simple stuff. But understanding that, yes, this is a problem, and this is a problem, and the more dependent we are on a website, the more critical an impact actually becomes to us. Okay? Really easy, right? The faster you drive, the more impact the car crash has. Okay. So awareness is the first thing. The second thing is building staff. Okay? There are two different camps when it comes to the security world that I live in. The first one is the OWASP world. Okay? OWASP is an organization that's a community around web application security. Okay? And what they do is they go out, they find developers, and they teach the developers how to write better code. That's cool. Okay? But most security people out there have background in operations, so they deal with phishing, IDS, firewalls, things like that. Okay? Those folks don't necessarily understand web applications. So right now, where I find people that can live in both of those worlds, so they have a programming background, they have a security operations background, I find them and I hire them, and then I use them to actually provide services to my customers. Those folks are very, very rare. They're very, very hard to find. Okay? It's just a fact. And when you do find them, they're very, very expensive. Okay? I'd say right now throughout Asia, there are definitely not enough of them. Throughout the Philippines, there's definitely a critical shortage there. So any opportunity you can have to build capabilities, either build it from a national level, build it from a company level, take that opportunity and do that. Okay? And then the last thing that you can do is the information sharing build an information feed for yourself to become smarter to identify attacks and respond to it, because these are very much just what we call flavor of the month. Okay? So an attack will come out, somebody will get a new technique, they'll build a tool, they'll go use the tool, they'll use it for 3 months, 4 months, and then they'll find a new vulnerability. Okay? And so, like I tell people all the time, I've got protection against all these attacks. you don't necessarily need me or my technology to protect against it. There are other ways to do it. But when it changes next month and the month after and the month after that, then we'll adapt with it and we'll tell you how that particular attack is happening. Okay? I'm going to finish with, well, nah, skip that one. Want to finish with a little bit of our evolution as a company. So, not that everybody needs to know that, but the piece that's important is that web attacks have followed roughly that same pattern. Okay? And the way that we started was, let's take websites, get them online, get people sharing it, running a website, get that information out there. Then people realized, well, hey, I can crash the website, I can deface it, I can put my own message there, or I can steal data out of the application. So then we created a web application firewall. Okay? There are some others that are out there. There are even some that are built into the web server that you can use. Okay? So we created version 1 of our WAF in 2009. Okay? And then we'd have these really surreal conversations. We'd sit and we'd talk to people, and they'd say, well, how do I configure this thing? What should I turn on? And we said, well, you know what? We don't necessarily know because it's your website. And they'd say, yeah, but you're the vendor. And we'd say, yeah, but you're ultimately responsible for it. So out of that, we realized that we needed to create better services and a managed security offering. So we built that. Then we realized that we had a lot of customers that were getting attacked all the time. So we built my team. We built CSIRT, okay, to do incident response. Then we realized that bots were a problem. So we started building things around bots, trying to manage those to keep them from impacting the availability. Okay? Then we built a network DDoS, or we bought a network DDoS company that could deal with some of the other problems that weren't web. Okay? And so over time, we've just been evolving and evolving. That's what people are doing today in the web security world, and that's what they'll continue to do, is continue to evolve, continue to build capabilities. All right? And that's all I have. Thank you very much.
A big hand once again for Michael Smith.